good morning, good morning. I will be with you in a few minutes. For now, you can start thinking about this question here. I am a number. I am in the 10 times table. I divide exactly into 100. What number am I? Also, if you could grab some bricks or blocks or something, that would be awesome. Oh, man. Lost all the bricks I was using the other day. That was silly of me, wasn't it? Alright, these things happen. Okay, good morning, Maths Mob. How are we doing? It's Friday and I love Fridays. And it's sunny outside, so thank you so much for being here with me because, well, actually, maybe you could be doing this outside. I was thinking like you'd have to be on a computer and you'd be inside, but you can take a computer outside. You could totally do that. I just had this panic that I was on mute. I'm not. That's good. That's happened multiple times. Good. Right. So we are here doing my free functional skills GCSE lessons. So essentially, I'm going to spend the next 2 years going through all the stuff on Edexcel Foundation GCSE. We'll cover everything that's on GCSE and on IGCSE. But as it happens, we'll also cover everything that's in Functional Skills 1 and 2 as well. So I'm going to start off by focusing on everything that's in Functional Skills 1 and 2. And then we'll work our way through. My aim was to get through Functional Skills 2, 1 and 2 the first year. I don't think that's going to happen. It might be a little bit longer than that. But we'll definitely manage it all within 2 years. Know exactly what you're doing, though. These sessions, I'm going to give you my mega teaching experience brain of the last 15 years of how to do things. But you'll need to do extra bits as well if you're taking an actual exam or sitting anything. I like to teach for real life understanding though. So, work how it works best for you. But if you are a square, I've just added to my workbooks that you'll get exam questions too to practice every week. I'll talk about that in a bit. Right, today we're looking at multiples, factors, and primes. No, we're not. We're just looking at factors and primes. No, we're just looking at multiples. I decided to split it up a little bit because things were going a little bit too fast. So we're just going to look at multiples today. Multiples and lowest common multiple. I changed my mind, so I've slightly advertised wrongly. Apologies about that. Right, let's get started. So I asked you a question. I asked you what number I could be based on a few bits of information. I'm in the 10 times table. Oh, I've got Lego everywhere, so I can't get this stable. Give me a sec. Why does everything seem really zoomed in today? I feel like everything seems super zoomed in today for some reason. And it's really, really big. And I'm having to move you way, way, way away to be able to read anything. Right, I'm a number. I'm in the 10 times table. I divide into 100 exactly. What number am I? Okay, so 10 times table, this bit here, when you're talking about some things times table, you're talking about multiples of that number. That's a key word to do with maths. It's frustrating because in everyday language, we don't use it. We kind of do. We sort of do. If you're going to buy multiple of something, you're expecting to buy lots of it, but then you wouldn't necessarily use it to describe the number. So if I was talking like packets of, I don't have any sweets. Why am I looking around? If I was talking about packets of sweets, so we might say I'm going to buy multiple packets of sweets. You wouldn't then use it to describe the number of sweets altogether, which is what we do in maths. A little bit frustrating. So multiples is something in the times table. So here I'm looking for a number in the 10 times table. So I'm going to want my 10 times table. I'm going to start writing this out. Oh, glare, me and glare, we're just not having a good time again. So multiples of 10, I've started writing out some multiples of 10, 10, 20, 30, 40, 50, so on. You might notice that I'm only looking at positive numbers here. I'm not looking at negative multiples of 10. I don't know exactly how we're supposed to, you can have negative multiples. I've never determined exactly why we have to use positive numbers, but we do. Okay, and I divide exactly into 100. So I divide exactly into 100. So this is another sort of keyword. Next week we're going to go into did I just say keyword? Oh man, what? I've just made myself want to be sick. It's like a mathematical word. Again, factors, we use it in a different way to real life to what we use it mathematically. In maths, a factor means a number that divides exactly into another number. So if we're talking about 100, I'm looking at numbers that divide exactly into 100, giving a whole number answer. I'll show you what I mean here. Factors we're going to dive into more next week. Okay, so factors of 100. Oh man, I've circled everything. Oh man, I'm so annoyed with myself. I've gone too wild on this PowerPoint. I've gone too fast. So what I'm going to do is I'm going to get a pen and write them out instead. So factors of 100, I'm looking for things that multiply to give 100. So things that multiply to give 100, I'm going to start off with 1 times 100. So 1 and 100 are factors of 100. 2 times 50. 2 and 50 are factors of 100. 3, I can't divide exactly into 100. If I do 100 divided by 3, I get 33.33333, and it goes on forever. So I can't put 3 down. 4, I need a better pen, Ruth. Come on, where's the inky pens? Where are those inky pens? 4 goes into 125 times. 5 goes into 120 times. 6 doesn't divide exactly into 100. Neither does 8 or 9. 10 goes in 10 times. I'm going to write that in the middle because it's 10. I don't want to write it twice, basically. So these are factors. We're going to talk about those a little bit more next week. So if I look at those, let me shift it up so you can see my multiples and my factors all at the same time. What am I doing? Why am I even talking like that? Oh gosh, sometimes my brain. Okay, so what you might notice is there's some numbers that are both factors of 100, i.e. they divide exactly into 100, and multiples of 10. And this is where my PowerPoint gets helpful again, because I did this. I did this. This is what I did. I circled the numbers that are in both lists. So 10 is in both. 20 is in both. 50 is in both. So if you said, I am 10, 20 or 50, then you are spot on. I could have been either of those. I mean, I was going to say I've got multiple different personalities. It does seem like that this morning, actually, doesn't it? It does seem like that. Some days, this is just what happens. So I asked you to bring some bricks. That's because we've got a little tower challenge. When I said bricks of the same size, I mean they need to be the same height. So if I'm putting them on top of each other, because I'm going to compare towers. So I'm using Lego because they're the same height. If they're not the same width, it's not so much of a problem. Okay. If you've not got those, you can draw them. Squared paper is really good for this because then you can use the squares instead of the bricks. So the first challenge, I'm going to explain it twice. Some people prefer it when you can see me and hear me. Other people will prefer to read this. So I'll also show you the ready version. Okay. Good English there, Ruth. You're going to build 2 towers. Tower 1, you can only add 2 blocks at a time. That's confusing, isn't it? Tower 1, 2 blocks. Just realised that. So I can put 2 blocks together. That's the first bit of the tower. Then I would need to put another 2 blocks together to add to this tower. Yeah, so I can only go up in 2s. Tower 2, you have to use 3 blocks at a time. So I'm going to go up in 3s. So I would have to add 3 blocks like that. And then when I want to add to it, I can't just add another block on top. I would have to add another 3 blocks on top. Okay, and keep going. So the idea is that you do that until both towers are the same height as each other. Okay, so I'll show you that again. Oop. I'm telling you, it's super zoomy this morning. So tower 1, you can only add 2 blocks at a time. Tower 2, you can only add 3 blocks at a time. Stop when your towers are the same size. Go, 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 go. I'm going to give you a couple of minutes on this. Some of you have probably already done it and you're like, yeah, come on. I'm just sat here chilling. If you want to, you can keep adding to your towers and see if you can make them the same size again. Explore some more. It's up to you. I don't want to tell you what to do. You know what. You can work out what you want to do for yourself, can't you? Okay, so how are we doing with that? How are you doing? Have you got 2 towers the same height? 2 towers are the same height as each other. So I'll show you mine. So my, I'll show you the whole process. I'll show you the process of what I did. I'll just put it down here. I'm going to have to build my towers like flat on the side so that you can see them. So I started off with 2 blocks on my first tower, 3 blocks for my second tower, and we can see they are not the same height. So I added on 2 blocks onto my first tower, still not the same height. That one's now taller. So I'm going to add 3 blocks onto the second tower, still not the same height. And then I'm going to add 2 blocks onto my last tower, and we should end up with 2 towers that are exactly the same height as each other. We've got 2 lots of 3 in the first tower and 3 lots of 2 in the second tower. So both of them are 6 bricks or 6 squares or whatever you used high. So what we've done here is actually we explored multiples. These are multiples of 2. We started with 2 blocks, then we added 2, so we got 4 blocks and then 6 blocks. So that's like the 2 times table, multiples of 2. With the second tower, we look at multiples of 3. So we started with 3 blocks and then we added on another 3 blocks to get 6 blocks. And at that point, we had the same amount in both towers. We're going to try another challenge now. So same idea again. Get your bricks. You want to pull them apart, but slightly different this time. This time with tower 1, you can only add 4 blocks. And tower 2, you can only add 6 blocks at a time. So tower 1, you're adding 4 blocks at a time. Tower 2, you're adding 6 blocks at a time. So again, I'll turn it around so you can see the words for those that like reading what to do. So same challenge. Stop when the towers are the same height as each other, but slightly different rules this time. Okay, I'm going to give you like, I don't know how long these things take. It's so hard when you can't drop to anyone. How are we doing with this one? I'll give you I'm going to count to 10 in my head and then I'm going to talk. Okay, so this time, what did you notice? Anything similar? Anything different? I think. Okay, so this time I did started with 4 blocks in my first tower, and I had 6 blocks in my second tower. I've just realised I've not got enough hands to do this by holding these up. So I'm going to put it, yeah, I'm going to flip you down. Okay, so first tower is 4 blocks. Second tower is 6 blocks. So I need to add to my first tower. So I add another 4 blocks, and that's going to make that one higher. So I need to add 6 blocks to my second tower, like so. And now that one's higher. So I need to add 4 blocks to my first tower. And now these are the same height as each other. So I needed 3 lots of 4 and 2 lots of 6. So we've ended up with 12 in each of them. So similarly, again, we've got the multiples of 4. So the 4 times table. So it was 4, 8, 12. And then multiples of 6. So this is the 6 times table. 6, 12. Last time we had 2 lots of 3 and 3 lots of 2. So we just did 2 times 3. That gave us the height, 6. But this time, that wasn't exactly the same. And we're going to have a little bit of a look at that in a minute. When we do, this time we had 3 lots of 4 and 2 lots of 6. If you did carry on though, you could have done 6 lots of 4 and 4 lots of 6 and got a tower of 24. Well, 2 towers of 24 actually. And it would have been the same height again. But it wasn't the first time they were the same height. So you may have predicted that the heights were going to be 24, but actually we could get the height as 12. We'll look at why that is very soon, very, very soon. Okay, so what we were doing there was finding something called the lowest common multiple. So you've got multiples of 4, multiples of 6, and it was the first one in both lists. So that's some mathematical language that I'll talk about in a second. I did promise somewhere, I can't remember where, on my advertising that I'd tell you a little bit of a story about our family and our garden. Back in, I think it was the Queen's Jubilee, we live like around, like our houses, we're all semi-detached houses around, like in a bit of a D shape, around a bit of grass, and some really nice people have clubbed together and they own this bit of grass in front of our houses so that people can play sport on it and things like that. And during the Queen's Jubilee, we had a big celebration out there, big party. It was really good fun. The people that were organising it got very, very stressed out there because our garden, we like to encourage wildlife and nature into our garden. So we let it grow really, really long. And one of the organisers came past like the day before and saw my husband mowing the front garden. And he was like, oh, I'm so relieved because if you hadn't done that, I was actually going to come in the night and mow your lawn. I was like, I wonder if that works all year round. If we just leave it, somebody will just turn up and do it for us, or whether it's just for this celebration. But my husband actually felt quite bad because we found like frogs and all sorts in it. It was really cool. It had worked. It had encouraged wildlife, and then we just got rid of it all in one go. I've actually read recently that no mow May is a bit ridiculous for that sort of thing because you encourage all the wildlife in and then you just get rid of all of it. Anyway, so this is a story about my husband cutting our grass, because just to highlight that I've tried to make a question that relates to real life here, and some of it's true and some of it is tweaked just a little bit. Okay, so functional skills 1 and 2, you'll always have questions like this where it's related to an actual real life problem. Now with highest common, it varies in maths. Some people prefer wordy questions, some people prefer non-wordy questions. In this topic, I find most people prefer wordy questions to non-wordy questions, which is odd. Yeah, often it's the other way around. Our back garden faces south. This bit is true. So the grass grows pretty fast. Also true. My husband cuts the grass in our back garden every 3 weeks. I bet it's debatable. Our front garden faces north, so the grass goes slower. That bit's true. It doesn't get much sun. He cuts the grass every 5 weeks. Also debatable. He cut the grass in both gardens today. A little bit of a lie. When will he next cut the grass in both gardens again? So essentially what I'm saying is the back garden is cut. The grass is cut. I refuse to cut the grass. This is definitely my husband's job. Is cut every 3 weeks. The front garden is cut every 5 weeks. If it was cut today, So let's just pretend it was cut in the front and the back garden today. When will my husband then next cut the grass in both gardens? So you can answer me in number of days or number of weeks, whatever suits you. I mean, you could do hours if you really want, but yeah. When will they next both be cut again? Have a little think about that. See if you can answer it. See if you can do this by thinking. It is good practice if you're going to take an actual exam to practice writing it down though too, because you'll need to do that, particularly for GCSE. How are we doing with this? Have a little think. Should we see? Okay, so I'll tell you how I'm going to show you my way of doing it, but there are other ways. Don't panic if you don't write it exactly the way I do it. So I've got front and back garden. So I've got F for front, B for back, because I'm a mathematician and mathematicians are inherently lazy. So the front garden is being cut every 5 weeks. So it's going to be cut in 5 weeks' time, in 10 weeks' time, in 15 weeks' time, and so on like that. So these are multiples of 5. The back garden is cut every 3 weeks. So in 3 weeks, it'll be cut, in 6 weeks, in 9 weeks, in 12 weeks, and so on like that. These are multiples of 3. But I want a time when they're both going to be cut at the same time. And so far, I've not got a number in both lists that's the same. So I need to keep going. This one's still a lower number, so I'm tempted to go with that first. I'm still adding on 3, 15. Now I've got a number of weeks in both lists. So in 15 weeks, they are both being cut at the same time. So we could do 15 weeks, or you may have done that in days, say 15 times 7, which off the top of I think is 105 days. She says. I think is 105 days. So yeah, this is essentially a way of finding the lowest common multiple. Functional skills on functional skills 1 or 2, it would be a wordy question like this, applying it to real life. In GCSE, they could actually say find the lowest common multiple of 5 and 3, and you would be expected to know that you're looking for multiples of these numbers, and then it's the first one. You could keep going with these. Eventually we'll get to 30 in both lists as well, but the problem is 30 wouldn't be the lowest one. So like lots of things in maths, the language here is a big thing. Language is the biggest barrier to understanding lowest common multiple, which I think is why a lot of people find the worded questions for these a lot easier. So I just want to like hone in on the language a little bit here. So I'm showing you the same problem again. We've got the same numbers. We're looking for the lowest common multiple of 3 and 5. So the first word that I'm focusing on is multiple. So I'm looking for multiples of 3 and 5. So these are the multiples of 3. These are multiples of 5. I could keep going with both of those lists. Then I'm looking for common multiples. So things in both lists. So 15's in both lists. And the 0 from here is skipped away, but 30 essentially is in both lists as well. And then the last word is lowest. So I'm looking for the smallest number that's in both lists. So 30 was in both lists, but that's bigger than 15. So I was looking for 15 to be the lowest common multiple. Okay, so that language is super important. Now, sort of going back to the bricks here, could we have just done 3 times 5? Some of you may have noticed that. Did you notice that? 15 is 3 times 5. So 3 times 5 gives us 15, just like 2 times 3 gave us 6 with that when we were building our blocks earlier. So let's have a little look at this one here. Another wordy problem. Again, this is the sort of thing you would see in your functional skills. You could also see this sort of thing in GCSE, GCSE, but you could also like just be asked to find the lowest common multiple. Okay, so I live in Cumbria. My closest two cities are Carlisle and Lancaster. There isn't any buses. I had to make that bit up. But say there was. The bus to Carlisle leaves every 25 minutes. The bus to Lancaster leaves every 30 minutes. The first buses both leave at 9 a.m. When will the two buses leave at the same time as each other again? Okay, so I'll read that out. Like, so if you're a person that prefers looking, I'll read it out to you, and then I'll turn it on so you can read it again. The bus to Carlisle leaves every 25 minutes. So pretend this is a bus. Yeah, and this is a bus. This is the bus to Carlisle. Every 25 minutes, a different bus goes to Carlisle. I'll say it comes back and goes again. Leaves every 25 minutes. The bus to Lancaster goes every 30 minutes. So every 30 minutes, there's a bus going to leave from Lancaster. The first buses leave at the same time, going in opposite directions at 9 a.m. So at 9 a.m. they both go off to, I don't know why they make that noise. Just yeah, they do. At 9 a.m. they both drive off at the same time as each other. When will be the next time that they both drive off at the same time as each other? Okay, I'm going to turn you around again so you can read that and have a little think about this question. Any thoughts on this? If you're using a calculator, this one's interesting. You absolutely can do that. At GCSE, you're allowed a calculator for everything. So yeah, I'm intrigued if you're using a calculator, how you would approach this maybe differently to if you're not using a calculator. Okay, so I'm going to count to 10 in my head again, and then I'm gonna go through this. If you don't worry, if this is too fast, maths is not to be done at speed. You can use this as a time to think about what you would do, and then come back to actually doing it later. That's not a problem. It's not a problem. Okay, so some of you, let's have a look. I just need to check out what this answer is. Yeah, okay. So some of you might have thought to do, let's flip you down here so I can show you how I would write it. Some of you might have thought to do 25 times 30, which gives us 750, and that's in minutes, right? We'll come back to that in a second. I'm just going to put that out there. If we look at what happens, the bus to Carlisle's going every 25 minutes. Now, I find my 25 timetable not too bad because 25 and 25 makes 50. 50 add 25 makes 75. 75 add 25 makes 100. And then it's sort of like a repeating pattern. So I go 125, 150, 175. I don't know how other people feel like that about that. But yeah, I don't find that one too bad. Then for Lancaster, I'm looking at every 30 minutes. You might have done it in minutes and hours, I'm not sure, but I'm just going to stick to minutes for now. There's lots of different ways to do this, but for 30, I just think of like my 3 times table and stick zeros on the end because I'm timesing it by 10. So 30, 60, 90, 120, 150, 180, and so on like that. And some of you might have noticed that actually we end up with 150 minutes in both lists way before we get to 750, which was 25 times 30. So way before. 150 minutes is much, much earlier than 750 minutes. So this would be how many minutes till the next bus. Now, I often find with these questions actually that the multiple bit isn't too bad, and we are going to do a lesson on time. For now, I'll talk about it, about how to convert that into time, but we'll do a separate lesson on it too, because time's a bit odd. Everything else we do, well, not everything actually, most things we do in base 10 because we've got 10 fingers. But there are also things in base 12 because we've got 12 bits to add digits. They're like your fingers are split in 3, 1, 2, 3, like that, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's quite easy to count in 12s as well. It's also very, very divisible. That's where 60 comes from on our clock and why it's 12 hours in a day and so on like that. So if we want to convert the 150 minutes into hours, we can either do that divided by 60, or we can just count up in 60s until we get to 150. So we can go 60 is 1 hour, 120 would be 2 hours, 180 would be 3 hours. So we've gone over, that's too far. So we've got an extra 30 minutes left there. So it would be 2 hours and 30 minutes. And 30 minutes. So that would be, if we start at 9 a.m, 2 hours and 30 minutes after that will be 11:30 a.m. I'm actually going to rub that off and show that a little bit better because I've got a little bit of a better way of representing that, which I think is easier to understand for people. So if we're going 150 minutes, so I just showed you this bit, 150 minutes. If I'm converting that into hours, there's 60 minutes an hour. So 1 hour is 60 minutes. So that's 1 hour. 120 minutes is 2 hours. And then 180 minutes would be 3 hours. Well, we were only looking for 150, so it's in between here. And the difference between 120 and 150 is 30 minutes. So it's 2 hours and 30 minutes. So then if I want to do 9 a.m. plus 2 hours and 30 minutes, oh, I'm writing a P instead of a 9. That's writing upside down for you. 9 a.m. I'm going to add on the 2 hours, which takes me to 11 a.m. And then I'm going to add on the 30 minutes separately, just to make that a little bit easier to work with. And that takes me to 11:30 a.m. Okay. So why didn't it work just to do 30 times 25 there? It's not that it didn't work. There would be 2 buses, theoretically, unless they stop, because that's quite a long time away. That's 12.5 hours between them. But there would technically be 2 buses leaving in 750 minutes as well. But it's not the first time that happens. So the first time that happens is the lowest common multiple. 750 is just another common multiple. We're going to go into factors a little bit more next week, so I'm not going to dwell on this too much, but I do want to show you a little bit about factors that explains why this doesn't work. So 30 times 25, if we look at the numbers 3 and 5, which are what we were doing before, where we could just do 3 times 5. Factors are numbers that multiply together to give the number or divide into it exactly. So the only factors of 3 are 1 and 3, and the only factors of 5 are 1 and 5. These two are prime numbers. But 30 and 25 have more factors. 30 you can get by doing 1 times 30, 2 times 15, 3 times 10, 5 times 6. And 25 you can get by doing 1 times 25 and 5 times 5. So these have got many more factors, and they have a common factor, which is 5. And that common factor is what makes it so that they have a lower highest common factor. The fact that they've got this common factor in between them. This one, the 3 and the 5, the only one these two have got in common is 1. And when you divide by 1, it doesn't change the numbers. But if we divided both of these by 5, it changes the numbers significantly. Okay, so that is why that doesn't work for those. Right, the last thing, this didn't go so well on Facebook. I confused a lot of people. So I'm going to try and explain this a little bit better. going to try and play a game called Fizz Buzz. And you can shout these out, you can write them down, you can just think them in your head, whatever suits you. The idea is we count to 20, but when you come across a multiple of 2, you shout fizz instead of the number. And if you come across a multiple of 3, you shout buzz instead of the number. And if it's a multiple of 2 and 3, you would shout fizz buzz. I'm going to give you an example, okay? And I'm going to do it with numbers written down so you can see what I mean, all right? So if we're going to go, I'm just going to go up to 6 to start with. So the number 1 isn't a multiple of 2 or 3. So I'd just say 1. Number 2 is a multiple of 2. So I'd say fizz. The number 3 is a multiple of 3. So I would say buzz. I'll put those there. The number 4 is a multiple of 2. It's in the 2 times table. So I would say fizz. 5 is not in the 2 or the 3 times table. So I would just say 5. And 6 is in both the 2 and the 3 times table. So I would say fizz, buzz. Like that. Fizz, buzz. So it's fizz for multiples of 2. Fizz if it's in the 2 times table. How to do a Z backwards. No, that's not a Z. Is that a Z? No, I can't do a Z backwards. There we go. Fizz. Fizz for multiples of 2. Buzz. Oh no, now there's 2 more Zs. For multiples of 3. Okay? Are you ready? Are you ready? I'm going to put the numbers on. Oh man. Wish us luck. Come on, guys. Come on. We can do this. We can do this. Okay. Are you ready? So the first number we know is 1. The next number is fizz. Then buzz. And then fizz. Then 5, because it's not in either of them. And then fizz buzz. 2 times table and 3 times table. Then 7. And then fizz. And the 2 times table. And then buzz. And then fizz. And then I think I might have got this wrong actually last time. 11. And then fizz buzz. The 2 and the 3 times table. Then 13. And then fizz. Oh, I went too fast. And then buzz. And then fizz. This one should be fizz. Oh no, fizz. That's right. Fizz, 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 fizz. And then 17. Not in either of them. And then fizz. This one should be fizz buzz. That's the one I got wrong. I'm going to change it now. Fizz buzz. Fizz buzz. And then 19. And finally fizz. Fizz. So 20 is fizz. Oh. Let me know how that went for you. It's really good fun to do live when you've got people like right in front of you. But when people can't respond, it's like maybe slightly harder. I don't know. You've got to try these things, haven't you? That is multiples and lowest common multiple today. We're going to do factors and highest common factor next week. If you've been live with me, there's a place on Facebook. You can say hi and I'll say hi back. If you've not done that and you want to do that, you've got some time now, just whilst I do a little bit of spiel about what this is. So these lessons are going to remain free for my home ed community. Just like Theatre of Science, I want to provide free lessons for my home ed community because I think it's so important to help people out. I also need to make a living. This is part of my job. So I charge £5 a month if you want to be a triangle to support me, and you'll get my Math Mob memo through the post, which is all about fractals, really exciting area of maths that you can explore at home through hands-on ways, and it's full of little activities and quizzes and engineering exploration there as well. And if you want to support with, you get that through the post with some stickers and some origami paper. And if you want to pay £6 a month, you can become a square. And I'm doing workbooks for the squares for this and the Maths in Motion lessons, my all ages maths lessons. Somebody's turned up to clean the windows. That's a bit creepy. And it's got all the notes from the lesson, but also at the back I'll do, I only have time for 3 or 4 questions, a problem solving, which is really important, and then a space for where you can find practice questions to do. And I've also started adding now places where you can find exam questions to practice too, because one lesson a week is great, but it's not going to be enough. If you actually want to pass an exam, you'll need to do the extra bits of practice around that too. Okay, right, I'm just going to check if there's any hellos and things, just so I can make sure I've said hello. Where have I got? I need to find Facebook. Oh, no hellos this week. Oh, bummer. Oh, well, yeah, I guess that just means you're here for the maths and not for Facebook, which is awesome. Absolutely fine. So I will see you all next week live for factors and highest common factor. Or you can come on Tuesday's lesson, which is live on Facebook at 10 a.m. I will see you there. Thanks very much, guys. Bye for now.